folks, degrees suck. For measuring angles, the only nice thing about degrees, and it is nice, is that you can add and subtract them in your head. 180 degrees, take away 50 degrees is 130 degrees. That's the only nice thing about them. There is actually a much better way to measure angles, and it's radians. Radians are glorious. Radians are great. They are so much more useful. The only problem with them, and it's a big problem, they're really tough to do in your head, and you can't. Sorry. We're going to start out with some review, though. Solve by hand. Cos theta equals negative 0.6293. I did show you how to solve these on your graphing calculator, and I showed you how to check your answers. Let's solve this by hand, because there's a couple of these on your take-home quiz. How would I solve this by hand? We said the first thing that we want to do is figure out what quadrant we're in. How do I do that? Cast rule. Which trig function did they give me? Cosine. Cosine, according to this question, was my answer positive or negative? So what quadrants is cosine negative? Got to be there and there. Okay? Which means I'm going to have one answer between 90 and 180. And one answer between 180 degrees and 270 degrees. Now what? Now I wanted to find the reference angle. And to do that, we took the inverse, the shift, that little negative 1 cos of what? Yeah, we had to recognize we don't use the negative to find the reference angle. Your calculator is going to give you something wonky. We put the positive 0.6293 in. Can all of you please find for me the reference angle? What do you get? 51 even? Yeah? How does that help? What that means, Cole, is that this angle right here is 51 degrees, and this angle right here is 51 degrees, because that's the definition of reference angle. It's always to the closest x-axis. Big deal. Well, that allowed me to find the first angle, which I called theta 1, and it allowed me to find the second angle, which I called theta 2. The first angle was that big. How can I calculate how big that angle is? 180 minus 51 degrees. 180 take away 50 would be 130, 129? The second angle is that one. How can I figure out how big that one is? 180 plus? Which is going to be 239? 31? That's what I said. Okay. I'm probably going to give you, I would guess, 3 or 4 of these on your test. They're going to be worth 2 marks apiece, maybe 5. In other words, this will be worth up to 10 marks of your overall test. You know what? I'll probably give you 1 of sine and cosine and tangent, and then some will be positive, some will be negative, and I'll probably give you 1 or 2 reciprocals as well. Check on your graphing calculator. Now, how did you check on your graphing calculator? We said this. You're going to graph y1 equals cos x, because that was the trig function. And you're going to graph y2 equals negative 0.6293. And we said when we graph both of those, the answer is where those two graphs do what? Do you remember? Intersect. Okay? We said pick a good window. The window we're going to go with is from 0 to 360 degrees. We're going to go once around the circle. And I usually go up by 30 degrees because that's a good scale. Every 30 degrees is a good spot to put a hash mark. Our y's, do you remember, what did we notice? What's the biggest sine and cosine got? Do you notice? Do you remember? Okay. They were between 1 and -1. So I'm going to go from, how about negative 1.5 to positive 1.5, going up by ones. So if I set up my calculator, if I go into the graph menu, and I set up my view window, I'm going to go from 0 to 360, scale of 30 degrees. Oh. Negative 1.5 to 1.5, scale, sure, 1. Of course, you're all trying this along with me, aren't you? I'm going to go cos x, negative 0.6293, draw. Should get that. The cosine graph, which looks like this. And there's the line negative 0.6293 high. And what I want is where these two graphs cross, because that's when they're equal to each other, which is really what that upper equation said. How can I do that? G solve, what do I want to find? Intersection. And I get 128.99. Hey, that's 129 degrees. And if I go arrow sideways, I get 231. Now is your chance, because we're going to have to know how to do this. If you can't get this, now is your chance to ask me, and I will come help you. Okay? You pause. I'll do a quick sketch. Let's see. It looks like I have, so there's my x-axis. Looks like the cosine graph does this. Yump. And I cross right there and right there. And then either on my graph or somewhere below, I would want to show the marker of the points. So this point here was what? 129 comma negative, 129 comma negative 0.6293. I got that right from my graph screen. There's my x, there's my y. And this point here, can I stop talking? Thank you. 231 comma negative 0.6293. So I will let you use your graph. I've showed you how to use your graphing calculators to check your answers when you're solving trig equations, but I'm going to make you solve them by hand. That was kind of a review of what we did last day. Here's the new stuff. Radians. Next page over. There are 360 degrees in a circle. The other way to think about that is 1 degree is 1/360th of a circle. Big deal. Well, we want to come up with a more generic way to talk about angles. And we're going to start out by talking about circumference. Rosanna's going to sit up straight, bless her heart. So I wrote here, what's the formula for the circumference of a circle? Who remembers how you find the circumference of a circle? I'm going to give you a hint. There's a pi in the formula somewhere. Circumference of a circle is 2 pi r. Okay? Circumference of a circle is 2 pi r. What do I mean by the circumference? That's once around. once around. Here it is. The measure of an angle in, not is, in radians is defined, this is how we define it, as it's the length of the arc forming the angle divided by the length of the radius. Say what? It's the length of the arc forming the angle divided by the length of the radius. Say what? As a picture, it's this. Can you fill in this line right there to point Q? Can you draw that in? Because that didn't come across when I stole this picture. If you draw an arc length that's exactly the same length as the radius, let me just pause. Click. 1 radian, look. If this length here is exactly the same length as the radius, that's 1 radian. 1 radian, look up, it's about, well, if my arm is the radius, if I draw an arc about as long as my arm, that's about 1 radian, give or take. Not 1 radian, because clearly the arc from the tip of my finger to the tip of my elbow is longer than my arm. Not 1 radian, because clearly the arc from the tip of my finger to my elbow is less than my arm, my radius long. 1 radian, about there. Why is that so handy? So what's the definition? If you take the length of the arc that traces out the angle and you divide it by the radius, that's that angle's measure in radians. So what would 360 degrees be in radians? I'm seeing a lot of people chatting. Guys, I need you with me. Sorry, but this is crucial. What would 360 degrees be in radians? Well, 360 degrees is all the way around the circle. Hey, what is all the way around the circle called? The circumference. What's the equation for the circumference? So, 360 degrees in radians is all the way around divided by the radius. Because radian is defined as the arc length divided by the radius. Hey, Roy, how many R's do you see on top? How many R's do you see on top? How many R's do you see on the bottom? Turns out 360 degrees is 2 pi radians. If you want it as a decimal, it's about 6.28, but pi is a yucky decimal to turn into a decimal. It's 2 pi. So, I just drew 2 pi radians, or 360 degrees. So if 360 degrees is 2 pi radians, what would 180 degrees be? Halfway around a circle. Just plain old pi radians. And this gives us our conversion factor. 180 degrees is the same as pi radians. 180 degrees is the same as pi radians. Little note, in math, the little circle up high means degrees. Radians have no symbol. And the reason is, this is actually meters divided by meters. The meters cancel. Or it's centimeters divided by centimeters. The centimeters cancel. Or they're technically unitless. You can, if you want to, write rad. That's technically wrong, but I'll live with it because kids don't like having a number with no units whatsoever. But technically, if I see a number and no symbol, I'll assume it's radians. Here's what that means. Turn the page. I'm going to start being fussy now. Once around the circle is 360 degrees, not just 360. If I see 360, I'm going to assume you meant radians. A right angle is 90 degrees, not just 90. If I just see a 90 and no degree symbol, I'm going to assume you meant that angle was in radians. Complete the chart. 360 degrees, how many radians? 2 pi, not 2 pi. 180 degrees, Brooke. 90 degrees, hey, what fraction of 180 is 90? 90 degrees is pi by 2. We used to say pi divided by 2, but we've gotten lazy over the years, and so our shorthand is we just say pi by 2, and we understand you mean divided by. 60 degrees. Hey, what fraction of 180 is 60 degrees? 60 degrees is pi by 3 radians. 45 degrees. Well, it's half of 90. What was 90 in radians? Pi by 2? What would half of that be? I heard someone say it. They were right. Pi by 4. Half of it is like having another 2 in the bottom, so you already had a 2. You know what? 45 degrees is pi by 4. I'm going to show you a way that you don't have to memorize these in a second, but uploading a lesson. But for now, I'm going to also show you how you can derive it. 30 degrees. Colin, you're right. Because 1/6 of 180. By the way, the one I always come back to, I memorize pi and 180 are the same. And because lots of numbers go evenly into 180, I can figure out a lot of angles in radians. Pi by 6. 1 degree. How many ones go into 180? It's pi over 180. What that means is if I want to convert from degrees to radians, I'm going to multiply it by pi radians over 180 degrees. This is my conversion factor. This is my conversion factor. It says, convert the following to radians, leaving your answer as an exact value in terms of pi. In other words, we want something pi by something. 270 degrees, I'm going to multiply that by pi radians over 180 degrees. I'm multiplying by a fraction. How do I multiply by fractions? That's the easiest mathematical operation of all. It's going to be top times top, bottom times bottom. It's going to be this. 270 pi over 180. Except I can reduce this. What is 270 over 180 in lowest terms? Now, you can do this a few ways. You can do this the long way. Caitlin, I notice a 10 goes into the top and bottom. See it? And 27, I think a 9 goes into the top and bottom. If you're really lazy, you can go 270 fraction button 180. What is 270 over 180 in lowest terms? What's 270 pi over 180 in lowest terms? 3 pi by 2. 270 degrees is 3 pi by 2 radians. Or if you want that as a decimal, 3 times pi divided by 2. It's 4.712388898, but it goes on forever, radians, because there's a pi in it. Rachel, radians are trickier to do in your head, but they're nicer for much other stuff. Brooke, you had a question. Because that's the conversion factor. If I want to go from degrees to radians, I multiply by pi divided by 180. The same way as if I want to go from minutes to hours, I times by 60. Sorry, divide by 60, got that wrong. If I want to go from days to hours, I times by 24. It's a conversion factor. If I want to go from years to days, I multiply by 365. If I want to go from degrees to radians, I multiply by pi divided by 180. 135 degrees, if I want to convert that to radians, it's going to be 135 pi over 180. But what's 135 over 180 in lowest terms? This is 3 pi by 4. (315 degrees). That's going to be 315 degrees times pi divided by 180, which is going to be 315 pi over 180. That's my conversion factor. What's 315 over 180 in lowest terms? (7 pi by 4). Try 225 degrees on your own. I get 5 pi by 4. No? Yes? 225 over 180? Right? It's type it into your calculator. 225 fraction button 180 equals? Okay. Sometimes they won't work out evenly. I'll let you know. If I say leave your answer as an exact value in terms of pi, what I'm saying, Seb, is use the fraction button and give me an answer like that. But sometimes the fraction won't reduce, in which case I'll say give your answer to the nearest tenth. So 73 degrees, well, I'm going to go times by pi over 180. Seb, did I say leave your answer as an exact value in terms of pi? In this one here, did I say leave your answer as an exact value in terms of pi? Say no. In the previous example, did I say leave your answer as an exact value in terms of pi? In this example, did I say leave your answer as an exact value in terms of pi? I said no, give your answer to the nearest what? What that means is don't worry about using your fraction button. What that means is just go 73 times pi divided by 180 equals. All of you need to go find where your pi button is. Try this. Do you know where your pi button is? Did you find it? Okay, it's Shift Exp. So as a decimal, 73 degrees is 1.274090354, blah, blah, blah. Well, I said to the nearest tenth, it's about 1.3 radians. You can write the word radians, you can write the word rad, but technically radians doesn't have any units. It's a ratio, and so you can just write 1.3. 306 degrees, can you convert that to radians, please? To do that, you're going to go multiply by pi over 180. Since they didn't say leave my answer as an exact value in terms of pi, I won't use the fraction button. I'll just go 306 times pi divided by 180. And I get 5.3 radians. Okay? That's going from degrees to radians. What if I give you radians? Can you go from radians to degrees? Sure thing. So, 2 pi radians, what did we say? How many degrees was 2 pi radians? That was once around the circle. So how many degrees? 360. What would pi radians be then? Well, it would be half of 2 pi, or half of 360. 180. Pi by 2, that's half of pi. That's half of 180. 90. Pi by 3, that's 1/3 of pi. 1/3 of 80. Pi by 4, that's, 1/4 of pi. 1/4 of 180, or half of 90. Pi by 6, 1/6 of 180. 30. Or 1 degree is pi over 180. In fact, Brooke, this goes back to your question. To go from degrees to radians, we times by pi over 180. To go from radians to degrees, we multiply by 180 over pi. It's the same as, it's the opposite of going the other way. In other words, if I go from hours to minutes, I times by 60. If I go from minutes to hours, I divide by 60. I'm flipping the conversion factor to go the other way. So let's try a couple of examples going from, next page, radians to degrees. Okay? So 3 pi by 2, I'm going to go 3 pi by 2 times, how do I go from radians to degrees? What do I multiply by? What does it say on your formula sheet? First, it's not 180. What does it say on your formula sheet? It better not say 180. Can someone tell me exactly what it says, please? Doesn't say 180. No, it can't say that. Read to me the whole fraction. There's a fraction. Read me the whole thing. Times 180 over what? It does say that, does it not? It doesn't say times by 180. It can't. It better not. No. So why were people reading that? Times 180 over pi. Now, how many pi's are there on top? 1? How many on the bottom? It's going to be 3 times 180 divided by 2, which is what on your calculator? Do it, please. 270 degrees. 3 pi by 2 is 270 degrees. Pi by 4, what's that? How do I go from radians to degrees? I multiply by 180 over pi. Gonna move you if I have to. I think it's going to be 180 divided by 4. 45 degrees. Let's skip C. Try D. 7 pi by 12. How many degrees is that, Rosanna? Try D. 7 pi by 12, please. Multiply by 180, divide by pi. Pi's cancel in this case. Doing this in my head, it's going to be 36 times 7, 210, 40, 252? Sorry, I'm way off. What is it? 105? Wow. 3.89. Hey, do you think this one's going to work out evenly, or do you think this one's going to work out to a decimal? How do you know, Jacob? You're right, because you're starting out with a yucky decimal. So I'm just going to go 3.89 times 180 divided by pi, and I'm going to do that on my calculator. I'm going to go 3.89 times 180 divided by pi button. 222.9 degrees. So try converting 5.63. Try that one on your own. How about 5.63 times 180 divided by pi? 322? 302. I did that backwards, didn't I? 322 degrees, 0.6. So here's the conversion chart, but I gave it to you on your formula sheet. Where do we use this? Well, everything we've done so far can be done with radians instead of degrees. First of all, use a calculator in degree mode to find the value to 4 decimal places. So on your calculator, find the sine of 45, please. Find the sine of 45 is point what? Point to 4 decimal places, 0.70, 0.7071. Secant. I don't do secant. What does secant go with? So this is going to be the same as 1 divided by the cosine of 135 degrees. 1 divided by the cosine of 135 degrees. And I get negative 1.4142. Double check me. Is that right? Right, to do secant and cotangent, it's 1 divided by sine and cosine and tangent. How do I know B is in radians? Okay, they told me, and there's no degrees. Now, how do I change my calculator to radians? All of you look up. To change to radians, you need to go into the setup menu, which is second or shift menu. Your screen should now look like this. Try that, please. And then you're going to have to go down arrow, down arrow, down arrow, down arrow, down arrow, down arrow, until you get to the angle. And I don't want to be in degrees. I want to be rad. Which is what? Okay, so put your calculator in radians, please. I don't know, what did I just finish saying? So you have to be in the typing numbers menu, and then it's shift setup, shift menu. Is that okay? Yeah. So now I'm in radians. Find the sine of pi by 4. Now look up. If you type this, you're going to get the wrong answer. You've got to put it in brackets. What's the sine of pi by 4? I think it should also be 0.7071. Yes, I think. That's because pi by 4 is 45 degrees. By the way, 3 pi by 4 is also 135 degrees. So I'm kind of hoping to get the same answer here. Let's see. Secant of 3 pi by 4 is 1 divided by the cosine of 3 pi by 4. 1 divided by the cosine of bracket 3 pi by 4. And I think I'm going to get negative 1.41242. See if you get that, please. So from now on, for the remainder of the year, anytime you're doing trig, the first question you're going to ask yourself before you do anything else, am I in radians or am I in degrees? How will I know? Take a look at part C. Which of those are in degrees? 1, 2, 3, or 4? 2 is? How do you know? Degree symbol. Is 4? In fact, they've been really sneaky. They've put an angle that you like in degrees, but it's not degrees. How do I know? No degree symbol. The other one that they love to do is they love to put a 90 in there because, ooh, we like 90. But if there's not a degree symbol, that's radians. So let's do all of the degrees questions first. Let's put our calculator back in degrees. So I'm going to do the second question. Cotangent of 135, that's going to be 1 divided by the tangent of 135 degrees. 1 divided by the tangent of 135 degrees. Do you get negative 1? Okay. The rest are in radians. Put my calculator back in radians. Find 1 and 3 and 4 on your own. I'll do them up here. Let's see if we get the same thing. I'll freeze the screen. See if you get what I got. I got negative 0.866. I got 0.5774. And I got 0.5253. Is that right?
Yeah.
Someone else got that, I hope? Yeah? Okay. A little bit more, we're done. The tricky part is moving around the circle in radians. If you've been zoning out, now is the time to pick up and sit up. I'm going to show you a great trick, a great procedure to get comfy with radians. It says this: for each of the following, draw the angle theta in standard position. State the principal angle, then find one positive, one negative coterminal. All right. What's the first angle that they gave me in part A? What's the first angle that they gave me in part A? Okay. We're good, Rosanna? Hands are soft. Now we're back and focused, yes? Okay. The best way to get comfortable in moving around the circle in radians is not to think in degrees anymore. I'm going to write something down. Do not write this down. Right here, how many degrees? 180? Don't write that down. Instead, how many radians right there? Roy, loudly. All of you, write this down. Do that. This is the best trick I can show you. I've never seen this in any textbook. That seems pretty... Oh, we're not done yet. Roy, what's the angle that they gave me? Part A, theta equals 3 pi by 4. Okay. You said pi. What number is in front of the pi? It's invisible, but what number is in front of the pi sitting there? The angle that they gave me, what's the denominator that they gave me? The angle that they gave me was what? What was the angle that they gave me? Give me a second here. Roy, what did you say? Okay, so pi. I always put, first thing I do, I draw, if they haven't given me the graph, I draw the graph, I stick a pi on there. That I can remember. What's the angle that they gave me? 3 pi by what? 4. So I'm going to argue that this isn't just 1 pi, this is 4/4. Nothing profound there. Actually, this question just fell apart. Look up, look up, look up, look up, look up. How far from here to here? 4 pi by 4s. How far from here to here? Halfway would be how many pi by 4s? 2 of them? Label that. I heard somebody say, I see it. Roy, what's the angle that they gave me? Well, if this is 2 pi by 4 and this is 4 pi by 4, where do you think 3 pi by 4 would be exactly? And you even did the degree conversion in your head. If you put the pi there and then work in the common denominator of whatever angle they gave you, you can almost always label the top and bottom of the circle and you'll figure out where you are. So you're telling me we are, yoink, right there. Yeah, yeah? Okay. And the principal angle is 3 pi by 4. So the answer to number 2 is 3 pi by 4. Now, then it said state one positive and one negative coterminal angle. Ready, Roy? How far this way? Don't say pi. Don't say 180. What direction are we going? How do we... How big is that then? I think negative 3 pi over 4 would be there, wouldn't it? What? Because what we've really done by labeling this carefully, I guess each eighth of a circle, each each little half wedge is a pi by 4, and there is 4 along the top and 4 along the bottom. So you're telling me, I think, Roy, that one coterminal angle, that one that I've drawn in red, is that okay? How could I find the other one? How did we find coterminal angles in degrees? What did we add or subtract? It's on your quiz. You guys are in trouble. What did we add or subtract to find coterminal angles? 360. 360 degrees. How many radians? Not 2. 2 pi. I gotta cut that off. It's not 2 radians, by the way, is only about yay big. 2 pi radians. 2 pi radians. So another angle would be 3 pi by 4 plus 2 pi. That's a dumb way to write it. Ready, Roy? I'm going to come back to you. Okay? I'm going to erase the red. I'm going to erase the negative here. Ready, Roy? Watch, 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 watch. How far? No, we're not going degrees. But what did we say because we were clever? 4 pi by 4. Ready? How far? How far all the way around? Ah. Right? 2 pi is 8 pi over 4. Don't add 2 pi, add 8 pi over 4. What's 3 pi over 4 plus 8 pi over 4? In your head. What's 3 pi over 4 plus 8 pi over 4s? What's 3x plus 8x? First of all, Rachel, what's 3x plus 8x? 11x. What's 3 pi by 4s plus 8 pi by 4s? 11 pi by 4s. One more, we're going to pause. I'm going to give you the rest of class to work on the take-home quiz. So it said, state the principal angle. We did, 3 pi by 4. Find one positive and one negative coterminal angle. Negative 5 pi by 4, positive 11 pi by 4. You're going to end up in the same spot. B. B. Colin, what's the angle that they gave me? Did you say negative? So I'm going to go that way. What's the denominator that they gave me? So I'm going to call this negative pi, but I'm going to call it negative 3/3. Which, by the way, would make this negative 6/3. But you know what? I'll come back to that. I'll leave that blank for now. What angle did they give me? Colin, what angle did they give me? Read me the whole thing, please, carefully and loudly. I can't hear you. How far from here to here? Negative 3 pi over 3. In other words, I need to divide this up into thirds, about 3 equal chunks. Can you see where negative 1 pi by 3, or negative pi by 3, a single third is? Right there. There's my picture. Now let's answer the questions. What do they want me to find? They want me to find the principal angle. Now the principal angle is that one there. let's go positive. Colin, I'm going to lightly scribble this one out, and I'm going to call this positive 3 pi by 3. What? On the other side is 6 pi by 3? Oh, pi by 6? I thought you were telling me what I was supposed to put over here. I was getting ahead of myself. 3 pi by 3. All the way around then would be 2 pi or 6 pi by 3. How big did you tell me this angle right here was? Can you speak loud? I can't hear a word you're saying. So it's pi by 3 big, negative, but it's pi by 3 big? So you ready? You ready, ready, ready? Look up, look up, look up, look up, look up. How far all the way around? 6 pi by 3. So how far from here to here? Not 6 pi by 3s. Foster. 5 pi by 3s, right? 1 wedge less than 1 pi by 3 less than 6 pi by 3s. So the principal angle is 5 pi by 3. Then it wants us to find one positive and one negative coterminal angle to that. How do we find positive and negative coterminal angles? Well, in degrees, we add or subtract what? 360. In radians, we add or subtract 2 pi, but I'm not going to use 2 pi. I'm going to say, okay, I can go 5 pi by 3. Don't write this down. Don't write this down. Don't write this down. I can go plus 2 pi, but how should I write 2 pi to make this math way easier? Write this down. In your head, what's a coterminal angle? 5 pi by 3 plus 6 pi by 3 in your head, please. Roy. Or if I start with the negative one that Colin gave us, which was negative pi by 3, I could subtract 2 pi, but I'm going to subtract 6 pi by 3. What's negative pi by 3? Take away 6 pi by 3. What number is in front of the negative pi, by the way? It's invisible. This is really negative 1, take away 6. Really? Negative 1, take away 6. Negative 7 pi by 3. We're going to practice this some more when I see you guys. Ooh, I don't see you guys until Monday. Is that correct? Your homework, and folks, need you to listen. Do you folks have some grad activities? I need you to listen, which means stay looking up here. Do you folks have some grad activities next weekend? Not this weekend, but next weekend? Then don't you dare not have the take-home quiz done for this Monday. Caitlin, I trust you're putting that on your phone and not actually just looking at your phone, because otherwise I'd take your phone away for the remainder of class. Your homework is the take-home quiz. I'll tell you what you're in theory capable of doing. I'm going to assign all this when I see you guys on Monday anyways. But certainly you can try, as for now, number 1, number 2, number 3, number 4, number 5, and number 6. But I'm going to finish this lesson off on Monday. You'll have time to work on this on Monday. But if you know you're going to be busy next week, start getting a head start.